On this Silverado, P0300 means the engine controller may be seeing crankshaft speed changes that look like an engine misfire. The truck may run rough, shake, hesitate, lose power, or turn the MIL on. If the misfire rate is high enough to risk catalyst damage, the MIL can flash. Keep the possible fault areas broad at the start: ignition, fuel delivery, injector or coil circuits, vacuum and air leaks, exhaust restriction, fuel quality or pressure, and engine mechanical issues. We are not guessing it apart. We are going to follow the misfire logic and let the counters, power balance, spark check, injector test, and mechanical checks narrow it down. Start with the basic system checks, then follow a structured diagnostic approach before getting into the P0300 path. This code is based on crankshaft speed variation, with camshaft position information used to help identify cylinder involvement. When you need to reproduce the monitor, keep the operating gate in mind. Engine coolant temperature equals -7 to 127 degrees Celsius, 19.4 to 261 Fahrenheit. Engine load greater than 30%. Engine speed equals greater than 1800 RPM. Fuel level equals greater than 11%. And system voltage equals 9 to 32 volts. Also make sure the supporting gate conditions are there, like crank and cam synchronization, no fuel cutoff, and no rough road signal. With the engine running, first verify there is no abnormal engine noise. If there is abnormal noise, stop the electrical diagnosis and move into engine mechanical diagnosis. If the engine sounds normal, perform the crankshaft position variation learn. After that, check for related codes in the cam sensor, crank sensor, oxygen sensor, fuel injector, ignition coil, fuel system, ignition system, or mechanical condition areas. If one of those is present, diagnose that area first, instead of chasing P0300 in isolation. If no related fault is set, watch the cylinder 1 to 8 current misfire counter. The desired result at this point is that it does not increment. If it is incrementing, move into the deeper testing path. If it is not incrementing, enable cylinder power balance and compare how the engine speed or engine sound changes when each fuel injector is turned off. Each cylinder should affect the engine the same way. If one or more cylinders does not respond like the others, move into testing. If they all respond the same, check the cylinder 1 to 8 current misfire counter again and confirm it still does not increment. Next, monitor the cylinder 1 to 8 current misfire counter while moving the harnesses and connectors at the engine control module, fuel injectors, and ignition coils. Then do the same kind of movement check on the vacuum hoses. The counter should not increment. If it does increment during one of those checks, repair the affected connection, harness, component area, or vacuum hose condition as necessary. If the counter stays clean, reproduce the operating conditions for the code, or reproduce the captured conditions from when the fault occurred, and verify P0300 does not set. If it stays gone, that path is all okay. For circuit and system testing, start with the vehicle off and make sure the CH51450A oscilloscope diagnostic kit and CH51450 lead A oscilloscope basic lead kit are available. If they are available, run the relative engine compression test and verify it passes. If it does not pass, stay with engine mechanical diagnosis. If the tool path is not available and the return point is unclear, pause, recheck the earlier diagnostic path, and avoid guessing. If relative compression passes, check that the listed supporting conditions are not present. That means no engine vacuum leak, no leaking, missing, or restricted exhaust condition, no contaminated, dirty, or low fuel condition, no high or low fuel pressure condition, no leaking, incorrectly connected, or restricted PCV condition, and no kinked, leaking, incorrectly connected, or restricted vacuum hose condition. Also keep non-combustion vibration sources in mind: accessory brackets, belt-driven components, the drive belt, driveline runout, brake rotor runout, tire and wheel runout, certain rough road inputs, and transmission operation can all matter in a misfire-style diagnosis. Tire and wheel assemblies with excessive runout can still create vibration even when balanced. If none of those conditions are found, turn the vehicle off and disconnect the spark plug wire at the spark plug for the affected cylinder path. Inspect the spark plug boot for carbon tracking, fluid intrusion, or visible damage. If the boot condition is present, repair or replace as necessary. If the boot looks okay, install J26792 ignition spark tester between the spark plug wire and ground. With the engine running, verify there is spark at the tool. Treat an erratic or weak spark as no spark. If there is no spark at the tester, swap the spark plug wire from the original misfire location with another known good spark plug wire from the vehicle. Run the engine again and watch the cylinder 1 to 8 current misfire counter. If the counter does not increment at the original location anymore, replace the spark plug wire that was originally at the fault location. If the counter still increments at the original location, continue with ignition system diagnosis instead of condemning the wire. If spark is present at the tester, turn the vehicle off and remove the spark plug. Verify the spark plug gap, heat range, and torque are correct. If those specifications are not correct, repair or replace as necessary. If the specifications are correct, inspect the spark plug for carbon tracking, fouling, or visible damage. If that condition is present, repair or replace as necessary. If the plug passes inspection, swap that spark plug with another known good plug from the vehicle, and run the engine again while watching the cylinder 1 to 8 current misfire counter. After the spark plug swap, if the counter no longer increments at the original location, replace the spark plug that was originally at the fault location. If the counter still increments at the original location, move to fuel injector balance. If the fuel injector balance test does not pass, replace the fuel injector that failed the test. If the injector balance test passes, verify there is no engine mechanical condition. If an engine mechanical condition exists, repair or replace as necessary. If no mechanical condition exists, that test path is all okay. If the vehicle is equipped with cylinder deactivation, there is one extra clue worth using. Command cylinder deactivation on with the scan tool, then watch the misfire counters when commanding it off. If the counters increment, inspect for a sticking valve lifter. After any repair, verify the repair, and confirm P0300 stays gone. Operate the vehicle in the proper conditions to make sure the misfire does not return. Then verify catalytic converter performance by operating the vehicle within the P0420 running conditions. The takeaway is simple. For P0300, do not jump straight to plugs, coils, or injectors. Confirm the engine is mechanically quiet, perform the crank variation learn, check related faults, use the misfire counters and power balance, then prove ignition, fuel, and mechanical condition in order. For more diagnostic training, visit stepdiagnostics.com.